Well, here the question says the integration of 1 by 4 plus 9x square dx. What this value is equal to? Well, again, if I see the term, I can make a guess that it might be associated with a formula, and the formula goes as 1 by x square plus a square integral dx. Yes or no? Yes. So what we'll do, first of all, let's bring this 9 common outside. I want to make coefficient of x square as 1. Got it? So when I take 9 common from denominator, my integral I is going to become 1 by 9 integral of 1 by 4 by 9 plus x square dx. Clear? And now we can apply the formula 1 by x square plus a square integral. And that is equal to what? I hope you can recall it. That is equal to 1 by a tan inverse x by a plus some constant c. So when I do that, when I apply it here, I know that my a square is equal to 4 by 9. So I can say that a value will be 2 by 3. Right? So if I apply the formula, it's going to become 1 by a, that is 1 by 2 by 3 multiplied by tan inverse x by a, that is 2 by 3 plus some constant c. Clear? And if I simplify, it's going to become 1 by 6 tan inverse of 3x by 2 plus some constant c. This will become the integral of the entire term. So what you have to remember is all the formulas which are associated in this chapter. Then only you will get an idea about how to go or how to solve the question further. Got it? Perfect. And therefore the answer will become option A. Well, moving further, here the question says that there is an integral I which actually contains some irrational terms. It is x plus x raised to 2 by 3 plus x raised to 1 by 6 in numerator divided by x 1 plus x raised to 1 by 3 multiplied by dx. So to find this integral, obviously directly there is no formula, right? Even if I think of any substitution, I'm not going to get the direct answer. So what should I do? Well, one thing which comes to our mind is, let's eliminate the irrational terms, because on my personal opinion, I don't want any irrational terms, right? So let's eliminate the irrational terms. And to eliminate irrational terms, we have to use a substitution. And what kind of substitution can we use? Well, I have x raised to 1 by 6, x raised to 2 by 3 and x raised to 1 by 3. If I have to eliminate all these irrational terms, I'll assume x as, let's say, t raised to 6. We can assume this, right? Now, when I take x as t raised to 6, I can directly say that dx will be 6 t raised to 5 dt, right? Now, let's eliminate x from the integral. So my integral I can again be written as, my x is going to become t raised to 6 plus x raised to 2 by 3. So what is t raised to 6 whole raised to 2 by 3, guys? Well, that is t raised to 4, right? So this is t raised to 4 and x raised to 1 by 6 is directly t. Divided by, I have again x. So that can be written as t raised to 6 multiplied by, I have x raised to 1 by 3. And we know that t raised to 6 whole raised to 1 by 3 is nothing but t square, right? So we have eliminated all the terms and substituted in terms of t, and dx again can be written as 6 t raised to 5 dt. Got this? Now let's try to cancel out some more terms. So what I'll do is, I'll take t common from this bracket. So it's going to become 6 times of t raised to 6, t raised to 5 plus t cube plus 1 dt divided by t raised to 6 and 1 plus t square. Clear? Now, you can clearly see that t raised to 6 is getting cancelled out. So, I am left with 6 can be taken out. T raised to 5 plus t cube plus 1 divided by 1 plus t square dt. Now what? Now how should I integrate this? Again, I don't have any direct formula, right? Nor any substitution is going to work. So what should we do? Let's separate the terms. So I'm taking these two terms together, first and second. So on separation, I'm going to get 6 times of t raised to 5 plus t cube divided by 1 plus t square dt, right? And one more term is 6 times of dt by 1 plus t square. Got this? Now, in the first term, in numerator, t cube can be taken common, right? So, if I take t cube common, I'm going to get a term like 1 plus t square, which is left out. And 1 plus t square is actually cancelling out from numerator and denominator. So, my first integral will become 6 times integral of t cube dt. And the second one is 6 times dt by 1 plus t square. And now we can directly apply the formulas. We already have integral of x raised to n with us. That is x raised to n plus 1 divided by n plus 1 plus some constant c, right? Now what is this integral? Dt by 1 plus t square? Well, that is similar to dx by x square plus a square, right? And we know the formula for it. It's 1 by a tan inverse x by a. So quickly let's apply both the formulas. So it's going to become finally 6 t raised to 4 by 4 plus 6. This is going to become tan inverse of t by 1. Since my a is 1, it's directly tan inverse t plus some constant c. Got it? And now we can substitute back our t value as x raised to 1 by 6. So when I do that, I'm going to get the first term as 3 by 2. T raised to 4 is nothing but x raised to 1 by 6 whole raised to 4, which is x raised to 2 by 3, right? So this is going to become x raised to 2 by 3 plus 6 tan inverse of x raised to 1 by 6 plus some constant c. And this therefore will become the final answer. Understood how we have simplified? So whenever you have irrational terms like this which are present in the question, think of some substitution to eliminate all the irrational terms. Got it? Perfect. And therefore, the correct answer will become option A. Well, here we have to find integration of sine inverse x dx. Now, this is an inverse trigonometric function and we do not have a direct formula for it. So, what should we do? Well, here we are going to apply integration by parts. And you know, for that you need two different functions, right? Now here I have only one function which is sine inverse x. So what I'll do, I'll take another function, let's say as 1. And I'll take 1 as integrable while sine inverse x as differentiable. Got it? So we'll apply integration by parts formula. Integration of u v dx is u times integral v dx minus du by dx integral v dx whole multiplied by dx. We have to find integration of this using by parts. So we'll take v as 1, my integrable function, and u as sine inverse x, which is differentiable. Got it? We are going by which rule? We are going by Eilert rule over here. The function which comes later is taken as integrable, right? So my 1 is considered as an algebraic function. So it is taken as integrable, while my sine inverse x is taken as I, or my inverse trigonometric function, and therefore a differentiable function. Got it? Okay, so guys, quickly apply this formula and let's see what do we get. So this is going to become u, that is my sine inverse x is going to come as it is, multiplied by 1 dx integral. Now you already know integration of dx, that is x. So I am writing x over here. Clear? Minus I have derivative of sine inverse x. And you know it's 1 by root over 1 minus x square. Right? And integral of v dx, well that is x times dx. Now the first term is already with us, that is x multiplied by sine inverse x. Sine inverse x minus, now I have to find integration of x divided by root over 1 minus x square dx. And how can we integrate this? Well, we can integrate this using some substitution. So either you can take x as, let's say, sine t, right? So when I take x as sine t, my dx is going to become what? Cos t dt. This is one kind of substitution. So when I substitute the values, my second integral is going to become, minus will come as it is, x is my sine t, dx is going to become cos t dt, and 1 minus x square whole square root again is going to become cos t. So this cos t is cancelling out, and you know what is integration of sine t? Well, integration of sine t is nothing but minus cos t, right? So therefore I can say that the final expression is going to become x multiplied by sine inverse x minus of cos t plus some constant c. And how should I eliminate back t? Well, I have my x as sine t. That means I can clearly say from here that cos t actually will be root over 1 minus x square, right? So this is going to become x sine inverse x plus root over 1 minus x square plus some constant c. And this therefore will become the final answer for the question. So have you understood how we have applied by parts and how we have taken the substitution also? Perfect. And therefore the correct answer will become C. Well, here they have asked what is the value of the integral, and they have given us the integral as 3x square tan of 1 by x minus x sec square 1 by x dx. So a long expression is written which involves algebraic as well as trigonometric functions. So how should we integrate this? Well, again to integrate this, we have the basic method available with us, which is integration by parts. To apply integration by parts, let's assume I is this integral. I'm separating it out first. So when I separate it out, it's going to become integral of 3x square tan 1 by x dx minus integral of x sec square 1 by x dx. And you know the formula for by parts. Now, I am going to apply by parts only in this first integral. I'm not touching the second integral, okay? In first integral, I'm going to apply by parts. And you already know the formula for that. Integral of uv dx is u multiplied by integral of v dx minus integral of the entire term which has du by dx as well as integral of v dx. Now comes the question, which should be my u function and which should be my v function. Means which should be taken as integrable and which should be taken as differentiable. To decide which function should be taken as integrable and which should be taken as differentiable, here I am going to take 3x square as an integrable function. So I am going to take it as v, and tan of 1 by x I am going to take as u. Why am I doing so? Differentiation of tan 1 by x is going to give me sec square 1 by x. Yes or no? And somehow I want to eliminate the sec square 1 by x term. So therefore, I have taken tan 1 by x as differentiable function. Got it? Perfect. Now let's quickly apply the formula in the first integral. So it's going to become u. That means tan 1 by x is going to come as it is. And you already know what is the integral of 3x square dx. Well, that is x cube, right? So this is going to be written directly as x cube minus, now I'll differentiate tan 1 by x. So what is the derivative of tan theta? Well, that is sec square theta, right? So it is going to become sec square 1 by x. And one more term is going to come. What is that? Derivative of this 1 by x, because we are going by chain rule, right? Don't forget to write that down. So 1 by x derivative is minus 1 by x square, further multiplied by x cube dx. And the second integral will come as it is, which is minus of integral x square 1 by x dx. Clear? Okay, so let me rewrite it again. So it's x cube tan 1 by x. And when I simplify this entire term, I know that x square and x cube is going to get cancelled and 1x will be left. And this minus is going to become plus. So it will become plus integral of x sec square 1 by x dx. And the second part of the question is coming as it is, minus integral of x sec square 1 by x dx. And now I guess you can clearly see that sec square part is getting cancelled out. And that was our target, right? That is why we assume tan 1 by x as a differentiable function. So this part got cancelled out, and finally I can say that my answer will become x cube tan 1 by x plus some integration constant c. Continuing further, here they have asked what is the primitive. Primitive means integral of the function x mod cos x. And they have given us the range of x. It's lying in second quadrant between pi by 2 to pi. So what is the primitive, or let's say integral of this? Now to integrate the function, I have to remove the mod first of all, right? And in second quadrant, we already know that cos is negative. That means mod is going to be removed by minus sign. Clear? So the function therefore will become minus x cos x. And now I have to find its integral. So if I assume the function as fx, I can say that here the integral, let's say that is I, will be integral of minus x cos x dx. Right? And here I have one algebraic function and one trigonometric function. To integrate this again, what am I going to apply? I'm going to apply by parts, right? So this minus can be taken out common, and we know the formula of integration by parts. Integral of u v dx is u times integral v dx minus integral of du by dx multiplied by integral of v dx. You have to remember this formula, and for that, keep on practicing all these questions. Okay? Perfect. Now, to apply the formula here, we already know what we have to do. We are going to take x here as a differentiable function, while cos x I am going to take as integrable function. Got it? So, if I apply by parts here by assuming these two functions, I can say that my x basically is u, while my cos is v. So when I apply the formula, it's going to become minus of, the first term is u integral of v dx. So u, that means x is going to come as it is, and integral of cos x dx. And what is integral of cos x, right, guys? Well, that is plus sin x, right? Don't write minus. It's plus sin x. So this is going to become x multiplied by sin x minus Now I'll differentiate x. So my dx by dx, well, that value is 1, right? So this is 1 multiplied by sine x dx. Got it? Okay. Now, when I solve this further, it's going to become minus of x sine x plus integral of sine x dx. And what is the integral of sine x, guys? Well, this value is equal to minus cos x. Clear? So this is going to become finally minus x sine x minus cos x plus some integration constant. Understood? A really simple question based on by parts. What you have to remember is just how to remove the modulus sign. Understood? Alright. And therefore the correct option will be B.